All right. Now, if we were to take an example, okay, to show how this formula works. Okay, let's say an unknown distribution has a mean of 100 and a standard deviation of 20. Sample size is 50. Okay, how do you figure out the probability? All right. So we know that the sample size, which is n, this is 50. We also know that U at x, or the average of the population, or the mean of the population, okay, this is 100. And we also know that the standard deviation, or the population deviation, this is 20. Now, given these values, okay, you can figure out both the probability and the percentile, given you know which percentile you're trying to figure out. All right. So, say for example, if you were to figure out the probability, so let's say probability x equals 20, say for example, or probability x is less than 20. Okay, and x over here represents time, for example. Let's say this has to do with manufacturing time for a certain product. Okay, these are your manufacturing units, sample size, so 50 units. Okay, over here, this is your average. Okay, let's say your average manufacturing time, let's say 100 minutes. Okay, your standard deviation, so this is the variation. So every time you take a sample, let's say sample one, sample two, sample three, the means will be different, right? So the means may be 20, the average mean, the sample mean, it may be 40, it may be 60. Okay, so you see a gap of 20 over here. This is your variation, or the standard deviation. That's what they mean by standard deviation. All right. So given what we have over here, given the values that we have over here, we want to figure out the probability that it will take less than 20 minutes for you to produce 50 units. Okay, so in that case, we will use our TI-84 calculator. Okay, and this is what the TI-84 calculator looks like right over here. This is an emulator, but this is something that you can use to figure out your calculations. So given these values, we'll need to type in these values. To do this, you will go ahead and press the second function on your TI-84, then vars. It will populate these values over here. It will populate these options over here. You will select option number 2, which is normal CDF. CDF stands for cumulative distribution function. Okay, and your cumulative distribution function is your normal distribution, which has a bell-shaped curve. And we talked about the bell-shaped curve in the last video as well as this video. So we're going to go ahead and type in 2 over here. So 2, which will give me my normal CDF cumulative distribution function. And we're going to now type in the lower value. Okay, we'll need a lower and an upper. So the lower value, okay, so we'll go back over here and check what the lower value is. Because x is less than 20, the lower value starts at 0. Okay, it could be a negative value, let's say negative infinity, or it could be 0. The result will be the same, depending on um, the sample itself, okay, depending on what you're trying to figure out. So in this case, we're trying to figure out time. Okay, time won't be negative. So for that reason, we'll take 0 as the starting point, and 0 is your lower limit. So we'll go ahead and type in 0 on this calculator over here. So let's say 0. This is your lower limit. Okay, and the upper limit, okay, let's keep this 20. Okay, because we want to figure out, okay, the probability of manufacturing, let's say 50 units in less than 20 minutes. Okay, so let's say this is 20. Your mean in terms of time, okay, this is this value over here. So this will change to this mean. So this is 100. So this is 100. This is your sample mean. All right, and your standard deviation, okay, this will be 20, which is the standard deviation for your population, divide by root of n, which gives you your standard error of mean. Okay, this is your standard deviation for your sample mean. So root of n, so root of 50, this will be 20 divided by root of 50. So 20 divided by, you're going to put your second function over here, use your second function, square root, and you'll type in 50. Okay, so 20 divided by root of 50, you'll press enter over here. Okay, paste the values, press enter one more time, and you see the value over here, this is 0. Okay, which basically means that the probability of you manufacturing 50 units in less than 20 minutes is 0. Okay, this is if the average time is 100 minutes, okay, for your entire setup. Okay, and the standard deviation is 20. Okay, so this over here, this is 0. Now, if you were to change these values over here, so let's say we go ahead and say that the mean is 30, the standard deviation is 10, and the sample size, let's say 100. All right, so we go ahead and punch in these values on the calculator. So the mean over here, again, wars, okay, and this will be normal CDF. Okay, if you're trying to figure out the values which are less than a certain value, so let's say x is less than 20 in this case, it will keep this function as it is. Okay, if not, if x is greater than 20, then you'll subtract whatever value this might be from 1. Okay, so 1 minus normal CDF, whatever value you get over here. Okay, so your upper over here will stay, okay, let's say in this case, your upper will become 30, okay, or, okay, let's just keep the upper as 20. Okay, so the upper is 20. Your mean is 30. So let's say this is 30. And your standard deviation over here, okay, because we changed the values, your standard deviation will be 10. So this will become 10 divided by your sample size. And your sample size in this case, okay, this is 50 over here, but we changed the sample size to 100. So this becomes 100. All right, so again, this is 10 divided by 100, and this would be square root of 100. Okay, so this is square root of 100. Okay, paste the values. All right, and type it into one more time. Again, this is 0. All right. Now, let's take a different value. So let's say this is normal CDF. Okay, so again, normal CDF is number 2. And let's say the lower value this time is 0, okay, and the upper value is 40. Okay, so now you're trying to figure out the probability of you manufacturing so and so units within 40 minutes. Okay, let's say the average is 30. All right, and your standard deviation stays the same. I'll just press enter over here. Okay, now this value changes to 1. All right, so this is basically how you use your TI-84 to figure out probability. So if this was P x is less than 40, 40 units, so anywhere between 0 and 40, this will become 1. All right, so that would be it when it comes to calculations for your sample mean. On behalf of V Electronics, this is Obey. Have yourself a great day.